Yes, Assalamualaikum and very good morning. You guys can hear my voice clear? Boleh? Yeah? Alright. Okay, so just to note that our test 2 should be next Saturday, 8 August, but we have problem with the internet at UTP, so our ULEARN also will be affected lah. So the test not going to be conducted on 8 August. Our test is on 5th August, meaning next Wednesday. Okay, tentative date is on the next Wednesday, 5th August. Okay, question will be covered until chapter 4 in your ULEARN. Okay, so we are going to finish this divergence and then chapter 3 and also chapter 4 if possible before your test 2. Okay, chapter 3 and 4 just utilization of formulas. Okay, that one should be okay. Not like, yes, test 2 next Wednesday lah, 5 August. Okay, so this now we want to proceed with this divergence. Divergence quite okay compared to Stokes theorem. So where you have a lot of formulas there, you need to do curl, you need to do the dot product. But for the divergence, we just need to apply the divergence. So what is the divergence theorem? So we just go through lah because we are going to finish this chapter and also go to chapter 3 today lah. Chapter 3 we only have 2. Okay, that one should be okay. 3, 4, 5 should be okay for you. Unless chapter 1, 2 here. Okay, because this is the last part of the vector calculus. Then we proceed with the numerical method lah. Okay. So this is the last part. We learned about Stokes already, Stokes theorem. We also learned about the Green's theorem. Now we have the last one, which is divergence theorem. So divergence theorem, we are going to concern with a vector field, okay, or the flux across surfaces that enclose a region of surface or space. So meaning basically it should be the area that enclose lah. Also later we have a closed area in the surface. So what is the flux? When the vector field going out of this solid or going into this solid. If going in, we have negative. If going out, we have positive divergence value. Okay. So what is the flux? Flux is the volume of fluid or vector field that passes through the surface in one time of unit. Okay, flux also given by the double integral of surface area. Okay, if divergence theorem Stokes theorem previously, we have this. But now in this divergence theorem, we have double integral of this lah. Okay, we have double integral here. Okay, that's for the flux. So what we interested is a surface that are boundaries of finite solid. That one should be closed. It should be closed. This one, if we look for all these three, all closed. And also it should be piecewise smooth. Okay, a closed surface may or not be smooth, but most of the surface that are in application are piecewise smooth. Not smooth, maybe you have like this lah, something that not smooth. Okay, a lot of maximum and minimum, that one not smooth. Okay, we will limit our discussion to the piecewise smooth surface only, where you have the inward or outward. So toward the interior and away toward the divergent negative, away from the interior is divergent positive. Okay, what is the divergence theorem? Let V be a solid whose boundary surface S is oriented outward if F, this is our vector field, where F, G, and H have continuous partial derivatives, so it should be differentiate, can be differentiated Then the divergence theorem, or the surface double surface integral of its surface equivalent to divergence F, and then you integrate the divergence F with respect to the volume of your solid. Okay, you have triple integrals. So the triple meaning volume. So you integrate this volume with respect to the, okay, you integrate your volume. Once you get your volume, then you apply it with the divergence. So the del dot product with the vector field is also equivalent to divergence of F. This one we already covered last week, how to get the divergence. So this one I just skip because this is unit sphere. Unit sphere, you need to, same like circle, you need to convert into r cos theta. If circle, x is r cos theta, y is r sin theta. Same here, you can solve this one direct. You need to convert this x, y, z into the phi. I forget about this one. So this one we already covered in the previous example during the Stokes. Okay, later we go through if we have time. Okay, but I don't think we cover sphere lah for you guys. Okay, then we have example 2. Let Q be the solid bounded by the parabolic Z. So you know already what is the parabolic, how to draw it. It's part of like parabola, but now in 3-dimensional. If you have negative here, okay, this one also 4 minus. You have negative. Same if negative. If your A is negative, which is less 0, your graph should be concave downward. Okay, so your parabola also should be concave downward like this. And 4 here basically is the intercept at Z, where this point should be 0, 0, 4. Okay, when x, y, z, x and y 0, your z should be 4. Okay, this is the surface. It says solid bounded, so it should be the surface now, and the xy plane. So xy plane, if you draw it in 3-dimensional of this parabola, xy plane, we know that means z should be 0. So it's bounded by z0 and also z equal 4 minus x squared plus y squared. So the parabola here should be bounded at 4, concave downward like this. So we have circle below, and also it also bounded below by this xy plane. Okay, this one is the blue one here, xy plane. So this is our bounded solid. Okay, above given by 4 minus x squared minus y squared, while below here given by z equal 0. Okay, so if you look here, now we want to find the flux. Flux, basically you just need to apply divergence theorem. And divergence theorem, what we have is three integrals. Okay, the divergence of f given by del f, integrate this respect to volume. This one also equal to double integral divergence of f. If this divergence f is given by del dot product f. Okay, so first we need to find this. We need to find this divergence f. Okay, divergence f, we apply the formula previously that divergence f is given by del dot product with f. So what is del? Differentiate, okay, respect x, respect y, respect z of your f. So what is f we have here? We have x cubed, y cube, and also z cube. So from here you can proceed, differentiate the x, okay, multiply the x with x component. So now we have is differentiate x cube respect x, you should get 3x squared plus, okay, differentiate y with y component. So 3y squared plus differentiate z respect to z component, we have 3 plus 3z square. All we have 3, you can simplify it, become x square plus y square plus z square. Okay, so this is basically the divergence f. So where you can put here, so triple integrals of 3 times x square plus y square plus z square. Okay, divergence is quite easy. Just need to know the boundary. So that one we covered already in triple integrals. Okay, so can you guys find it for me for the boundaries? Okay, now we already get this. We already find this divergence. Now we want to find the limits for these three integrals. So we know already the upper of z is given by here, 4 minus x square minus y square. If you refer to the solid, this is our upper z upper. Yz lower is given by 0. So our z now is equivalent to from 0 until 4 minus x square minus y square. So now we want, now we want to find the x and y, because you have 3 integrals, so you need to have 3 limits. So in the xy, remember x, now we just interested with x and y. You only have 2 variables. So you look at x and y, what you have is circle here. Okay, since this circle basically all through this, all through until z4 here, what you have basically is a complete circle bounded region lah. Okay, if you look from above here, you have like complete circle at the x, y plane. So you have circle. As previously mentioned, if you had a circle, obviously you need to use polar coordinates. So we now don't use xy, but now we will use r and theta. Okay, we use r and theta. Okay, so you need to get what is the maximum radius here. This maximum because we go through along these all circles, but the maximum is at z0. So what is the radius here? Z0, because this one part of the parabola here. You can just substitute z0 into this parabolic function. You can get the r here. Okay, so we just substitute at z0. Okay, this is our solid previously. Okay, you have this circle and this one given by z. Okay, now we're interested to get the radius here. Okay, so at z0 you substitute on this parabola. Okay, you get lah 4 equal x square plus y square. That means 4 here is r square. Then your r equal to 2. Okay, C is complete. So we refer to the previous one. Okay, now we know already this should be radius 2. Okay, so now our r is from 0 because complete circle. From 0 until 2 because complete circle also we get 2 until 2, 5. So complete the intervals here where you can substitute now. Okay, you can substitute here. Okay, this one I erase lah. Okay, this one what you have now is, okay, if you look here, you have numbers for both r and theta. So we can maybe start with r and proceed with theta. Okay, not the start lah. Here we have z. Okay, why z? I put the first one because here if you look at z, you have variables x, y. So you need to do this one first. And for the xy, now we don't have xy. What we have is r theta. You can proceed with r or you also can proceed with theta. This one doesn't matter because both numbers. So here r from here r 0 until 2 and theta from 0 until 2, 5. And our z is from 0 until 4 minus x square minus y square. Okay. Here you cannot proceed with your calculation. Why? Because if you look here, you have 5 variables. Okay, why we call it 5? Okay, we have 5 variables where, okay, what is our first variables? You ada, okay, you ada Z, you ada R, we have theta, we also have X, we also have Y. So we have 5 variables. Because we only have 3, so you need to change this X, R, X, Y also in the form of R and theta. Okay, in the form of R theta, you still cannot proceed. And remember, because now you change this one into R theta, you need to add here, multiply with R. Okay, every time you change into polar coordinate, this one you should add lah, multiply with R. This, your divergent F should be multiplied with R, the R theta. Okay, so here we have 4 minus X squared. So you need to simplify this Z also. We don't want the X and Y. Okay, from here, you can simplify your Z, where Z here equivalent to 0 should be no problem lah because already 0. This can be simplified as 4 minus X squared plus Y squared, and we know already from the divergence theorem, from the polar coordinates, that X squared plus Y squared always equivalent to R squared. So that means the Z here, the limit is from 0 until R squared. Okay, so no more X and Y. Here you can just rewrite Z from 0 until 4 minus R squared, R 0 until 2, and 0 until 2 pi for the theta. So the limits now complete all the 3. This one also we just put lah dz dr d theta, and our divergence also previously we have 3 X squared plus Y squared plus Z squared. Okay, still here you ada, we have X squared and Y squared. You apply here, this can be simplified as 3 R squared plus Z squared R dz dr d theta, the triple integral. So basically this is the final formula for this example 2. Okay, Z like usual, but since you have circles in the XY plane, in the XY here, so you need to translate into a polar coordinates and just apply the properties of polar coordinates that X squared plus Y squared always equal to R squared. So you simplify your functions now. Instead of X, Y, Z, okay, instead of you ada dx, dy, dz, you translate become dz, dr, d theta. Boleh guys? So this one lah, this one you need to change into r and theta. Okay, sequence doesn't matter. Here dz kat depan, nanti you confused. Okay, here we put kat depan juga lah. Okay, this one depend on our integrals. Okay, so final question is here. It is what you need to integrate. So maybe you guys can try. Final answer is equivalent to 96 pi. Okay, 96 pi is the flux of the vector field positive. So basically the vector field going out of this solid je lah, bounded above by this parabola and below by the XY plane. Okay, maybe boleh cuba dulu whether you get the 96 pi for the divergence for this question. Okay, try dulu. The range of theta of parabola is always 0 to 2 pi. Yes, if complete circle, but if the question example they mentioned in the first octant. So we know first octant only XYZ greater equal 0. So our theta not 0 until 2 pi lah. Okay, so our theta just half, just quarter of it. So 0 until pi over 2. It depend whether you punya circle tu complete or not complete. Okay, Maybe you guys can try 96 pi there. No, today triple integrals question not involve sphere lah. Okay. Okay. You guys get 96 pi. The final answer. Don't forget there we have r square plus z square times r. So expand it first. Become r cube plus z square r. Then proceed with the integration. Okay, kalau integrate z dulu tak apa. Should be just proceed lah. So you dapat z still there because you ada z square. So still need to expand lah. So what we have is okay, here you need to power 3, so triple expansion here. Okay, this one you should like this one integrate lah. So put down here what we have 16. Apa? With the expansion of this, you should get, okay, use your paper lah. So here, you expand it because you have all R. You integrate with respect to R, then multiply with R. So final answer, you should get 96 pi. Okay, for this question. Okay, any question for this one? Kalau tak ada, we proceed the next examples. Okay, because I think the integration you know already. Okay, if whether you need the substitution or not. But now what you need to know is how to get the functions. Okay, function that you are supposedly to integrate. Okay, proceed with the next one here. Okay, maybe you guys can try. Evaluate the surface integrals, double integral of the surface. Now with respect to ds lah. Given your vector field is x squared z cube, 2xy z cube, x z4, where S is the surface of the box as shown in the diagram below. Okay, if you have rectangular previously in 2D, okay, rectangular region. So you just take the number A, B, C, D for X and Y. If you have box also in the three-dimensional is the same. So all here just number. Just take the upper limit of Z and then upper limit of Y and also the upper limit of lower limit and upper limit of X. So this one should be no problem. Just take the number because we have box. Okay, so X, Y, Z done. No circle here, no need to use polar coordinate. So just proceed with the divergence. You put into the formula of it. Okay, formula of divergence. This one should be okay lah. Okay, because the limits all from 0 to 1. Okay, you can try this. Okay, in order to get the answer given is 1. Okay, I think this one you will try at your home. Okay, we have last example here. Basically, now you just need to apply the triple integrals of your vector field, of your divergence. Okay, maybe you guys can try this question, get the limits of intervals. Okay, for maybe 5 minutes lah to find the intervals X, Y, Z. So nak dapatkan the X, Y, Z. Later we discuss for this. Okay, 2x minus y square, 4xz minus y, xyz cube. So now the question is how to get the divergence and also intervals. Okay, try dulu for 5 minutes.
Madam?
Yes?
If we are solving the sphere question, okay, we need the S is equal to cos theta, right?
The rho cos phi sin theta, if I'm not mistaken lah. The rho, the formula that yang kita, we have the sin, we have theta, we have phi, we have rho. Rho is the radius of the sphere too. The theta is the angle in the from positive z and positive x, while the phi is angle from positive z.
How about just now, because r cos theta and r sin theta?
That one is circle. Kalau circle, r cos theta, r sin theta, circle. Circle.
How about z? No z.
Z just maintain as z lah.
Just s is equal to r cos theta and y is equal to r sin theta, that's all.
Yes, itu untuk circle. Tapi if for sphere, you kena guna the spherical coordinates.
Okay. Okay, thank you, madam.
Okay, sama. Yes, because it given there first octant, so first octant to XYZ all zero, and coordinates plane meaning X0, Y0, and also Z0. Coordinate to meaning the axis lah, axis X, axis Y, and also axis Z. So normally XYZ 0, because start with 0. Robbie, do you have any questions? Robbie?
No, madam.
No. Okay, because I meet you. Okay. So we proceed. So what is the upper and lower limit for the Z? What the answer that you guys find for this example 4? What is the upper and lower limit for the Z? Dapat tak? What's the answer here? For the Z. Z0 to 1, tak boleh. Z cannot be 0 to 1. Why? Because this one, example 4, not example 3, previously not example 4. Because you are if you look there, surface x plus y plus 2z. So basically this is not box. Okay? So not 0 to 1, but 0 to what? Because coordinate, so we know should we start from 0, but what's the upper limit for z? And how to get the upper limit for the z here? Any other answer? 1 to 0? Tak. How is 0 to 1? 0, no, cannot. Okay, no. 0 to 1, 0 to 2? Also no. No, don't give me number. It should be function. Okay, because you look there, upper is a surface. Surface to plane. How to get that? Answer not numbers lah. So you can draw it. If you don't, you can draw this, right? Okay, how to get this? Okay, if all power 1, basically they are plane. Okay, plane meaning flat surface. So how to draw it? X, Y, Z. So when Z exists, meaning all X, Y should be 0 lah. Okay, X, Y 0, Z should be 1. Here you put X 0 plus 0 plus 2Z, you get 2. So Z equal to 1. We want to draw this plane. Okay, the second one here, if X exists, meaning Y 0, Z 0, so you should get X now equal to 2. Same here, X 0, Z also 0, so Y should be 2. So you just connect these 3 points. Okay. Okay. So basically this is our surface. And it's said bounded by coordinates plane. So at the back here, you should have this boundary. Okay, at the back there. And below here also we have because first octant we know X, Y and Z all should be 0. So meaning kalau you ada X and Y exist, dia mesti in this region lah, all positive. Okay, so this is our solid basically lah. Okay, first octant and coordinates plane. And this is our solid. And from here, we can get the limit for the X, Y, Z. Okay, Z, if you look here, Z start from 0. Okay, if you look at Z axis only, it start from 0. Okay, we have Y here, X, Y lah. If you look from this plane, X, Y, here basically is this line, this plane XY. So from there you can dapat like this Z. What is the upper limit? Limit of this solid is like this, right? Here they go to this XY plane. Okay, and this should be the upper limit for Z, where it is 2 minus X minus Y over 2. You need to solve for Z here. Okay, Z is 2 minus X minus Y over T. L over 2 and Z until this line here, until the XY plane. So we already get the limits for Z is from 0 until 2 minus X minus Y over 2. So for this Z. Okay, now in order to get X and Y, you just draw the X and Y here. Okay, you draw our X and Y in the XY plane. Okay, still here you tak dapat rectangular region. What you get is in the XY plane. Okay, you look here, you ada point 2 go to 2. So you ada this line and this is your bounded region. Okay, on the XY plane. So you need to get, because this one not rectangular region, you need to get what is the upper limit here. Okay, if I want to proceed with Y, okay, if I want to proceed, okay, meaning here you ada dua variable, so this one you should integrate first, dz, our triple integral later, and then now you want to proceed with the dx, dy, or dy, dx. Okay, if I want to proceed with dy, so I need to get the function of y upper and also function of y lower. Okay, function of y upper and also y lower, because start from 0, y lower 0, but until this line. So you can dapatkan the equation of this line where this is mx plus c. I think equation of line you know already how to get. C is the intercept, m is the gradient. So from here we get negative x plus 2 lah. Okay, because same to 2. So your upper limit for y is negative x plus 2, while for the x, the last one, remember last always number, just take the number 0 until 2. Okay, so that's 3 limits for x, y, z that you need to substitute here lah. So here after z, I proceed y and then x. Okay, kalau you start dengan x tadi, you need to go to this direction. So this is the upper limit, go to 0. Kalau you buat dx, dy. Okay, but now I proceed dy, dx. So what is the upper limit and lower limit for y? Okay, so that's the intervals. Now you just need to complete inside here. Okay. This one, you should get the del dot f. Okay, differentiate this, respect x, you dapat 2, respect y, so minus 1, respect z, so this one basically what you need to integrate is z lah. Okay, or is 1. Okay, boleh? Answer is 2 pi 3. Boleh guys? Okay, boleh for this one. Okay, first, what is the Danish question? I cannot understand. Only one variable that will have limit in numbers. Apa maksud dia ni? Tak faham. So, how you decide whether dx, dy or dz? The one with the most variable, that one you need to integrate first. Okay? If you look there, interval z, you have two variables x, y. So that one you need to integrate first. You need to start with dz. Okay, and then you ada dy, dx. Okay, because now we have triangle, not rectangular region. So one of it must be function. So kalau you nak proceed dengan dy, the intervals of y, one mesti ada function. And then the last one that you integrate, only numbers. Okay. Gobi, you have question? Gobi, we cannot hear you. Gobi, maybe you can mute and just start. Okay, Gobi. Gobi.
No, madam, internet problem.
Oh, so I mute you, eh? Okay.
Okay.
Okay. How to know it is triangle? Basically, dia akan mention example for this question. Okay, we go question by question. Okay, we go through all examples here. Okay, these examples it mentioned in unit sphere. So how you want to decide if your function, if the question tak mention lah. Okay, if you ada x square plus y square plus z square and number here maybe a, this one is here. Okay, if you ada z equal negative x square plus y square, okay, all here should be same sign plus number also, it is paraboloid lah. Okay, you nampak x square plus y square, only x and y will have power 2 but z power 1 is paraboloid. But if your z is but here negative, depend whether concave upward or downward, depend on the sign. Okay, kalau negative here lah, kalau positive upward. If you have square root, also x square plus y square inside, but you have square root, this one cone. Okay, with the upward or downward also depend on the sign. Kalau this one positive, so you ada positive concave upward. If you have negative square root, so you have cone that concave downward lah, yet go to the negative axis. What else we have? If okay, x square plus z square, y square, q square done. Okay, so if this one constant lah, k constant. So this one is here. If you have x plus y plus z only, also k, this one plain. All power 1, it doesn't matter, maybe you have constant here, maybe number 2, number 3, number 4, doesn't matter, as long as all power 1, here it should be plain. If you have, like previously, you have x square plus y square, okay, a, and then constant k, okay, this one just standard form, so we learn about standard form, right? Z, okay, if your a greater 0, you have paraboloid that concave upward. If your a less 0, you have the paraboloid that concave downward. There is a paraboloid here. If we have a but square root, I think I asked you to draw the solid, right, and the region in our previous assignment, just to make sure you guys understand understand how to get the shape of the region lah. Okay, same here. If a greater, you ada cone. Okay, we have cone here. Okay, this one paraboloid that concave downward. But if you have square root, a also is the whether go to up positive or negative. Here you have cone that go to the positive z. If a less 0, you have cone that go to negative z. Cone here if square root. If no square root, you get the parabola here. Okay, here should be z lah. Okay, so basically all these 4 are basic. Basic sphere, you are the all square, plane, all power 1. This one doesn't matter, this one just constant. Okay, I don't put a lah. I don't put just this. Maybe what you have is put number. Ax plus by plus cz equal k. This one plane. ABC is the intercept. How to get? Make sure x, y 0 dapat z. Y z0 dapat x z0 dapat y. Okay, and if power 2, both x, y is paraboloid, and if you had the square root power 2, x and y, you have the cone. Okay. So like previous one, example, we have this. So meaning they are plane. So you need to draw it for the plane. Okay, what is the other question? We cannot see pointer. Yang lain boleh tak? How to know is triangle? Triangle, you look from positive Z. Make sure macam you go from the, if you, triangle meaning in the XY plane, meaning you try to look the solid from the positive Z. What should be the triangle look like lah? Okay, whether you dapat circle ke apa, that one all depend from when you look from positive Z. Okay, like the previous example yang this one tadi. Okay, this one, if you look from above here, okay, if you look this solid from this positive Z, tengok pada atas ni, you akan nampak this triangle lah. Okay, you can dapat, that's why you project it here. Okay, meaning you look this solid from positive. You look from above here, you akan dapat this triangle. Okay. Boleh. This one, all the solid region, all involved in the theorems that we learned previously. Okay, that's how we use it lah.
Madam?
Okay, yes.
Is this example, do we need to use the S is equal to R cos theta?
For example 4, tak perlulah because this one tak ada circle. Example 4 ke?
Example 2, madam, I'm stuck, I don't know why.
Example 2, yes, we need to use R cos theta because you ada circle. Okay, sebab example 2 previously, we have parabola, right?
Okay.
Parabola, so kalau you tengok from positive Z here, you akan dapat this circle, this one lah. So meaning you kena guna the polar coordinates, the R cos theta, R sin theta, only for XY. But for Z, just take the Z lah, upper and lower, and everything in terms XY, you need to change into the R and theta form. Okay, Z
Okay.
will maintain as Z. Okay, try, we should get 96 pi, okay? Maybe salah ke expansion code.
Okay, thank you, madam.
Alright, sama. So that's for divergence theorem. Divergence, I think you know already how to get del dot F. Okay, try to familiarize yourself lah how to find the del, the curl. Because that one just the you need to apply it later for the theorems. Okay. Okay, so I think that's all for divergence. Okay, we want, so now we complete the vector calculus part, the first part in the EM1. Okay, EM we have two chapters, two parts basically. First is vector calculus, the second part is numerical methods or numerical approximation. Okay, the first part susah sikit, but the second part is easier for you. Okay, so we take 5 minutes break before we proceed with the that numerical parts lah, numerical methods part. Okay, 5 minutes break. Okay, now we proceed. The second part of the EM1 numerical methods. Okay, the first, for this chapter 3, we cover roots of equation. So you can use your calculator. Okay, if you have polynomials, x cubed or x squared, how to get the roots. Example, sebelum ni, you ada example lah, x squared plus 4x plus 3 equals 0. So you get the x. Okay, just use your calculator, or x cubed or x plus 1. Use your calculator, x power 3, you get 3 roots at most. Okay, different roots. And but what if you have x4 plus 3x cubed plus 1? So 4, 3. So you cannot use your calculator. So this is where you need to apply numerical methods. Okay, this is where we need to apply the numerical methods, because we cannot like directly get the answer by using the formula. This one you can apply the formula b square minus 4ac square root. Okay, this one you can use your calculator, but for this case we cannot use this formula, the calculator or whatsoever. You need to apply numerical methods. Okay, you are going to cover 2 techniques in order to get the roots. First is bisection methods. The second one is Newton-Raphson methods. Okay, now this is the bisection. Bisection method is a root finding method that repeatedly bisects an interval and then select a sub-intervals in which a root must lie for further processing. Okay, basically the numerical method, you don't get exactly the right answer, but you get answer close to that what we are expected lah. Okay, close to the exact answer. So we have like root error here. Okay, example, this is the true answer, true value. But when we use numerical method, basically the answer that we get is close enough. Okay, or maybe the correct one lah, but basically not the correct one. Maybe close enough. Maybe you get here. Okay, this is the answer that you get. So the gap between the true value and the one that you get, this is what we call error. Okay, error. So now we have first case where GA less than GB. So this is your function. Examples, you have point A, you have point B, and this is your G function. Okay, if your GA is here, and this is our GB, the second point. So if you notice here, A, this is your GA, because now we use function, kalau you confuse, you can use function F lah. So this is your function B, GA less than B. Here you see A less than B. Okay, so basically for this, we need to use negative, positive. Just we consider it. Okay lah. Okay, now assume this is our axis. Okay, this is our axis X. And this is your point A, this is your point B. And GA less than GB, meaning A negative, while B here positive. Then this is the step in order for you to apply the bisection method. Okay, first you need to get the 2 points A and B, where when you substitute the A, you must get negative. When you substitute B into your function G, you get positive. So different sign here, negative to positive. So meaning we have the roots between, okay, we have roots between A and B. Okay, we want to find this root. Okay, find the midpoint of A and B. So you need to get the midpoint between A and B. That's the second step. Okay, first you need to get 2 points. Second, find the midpoints. And step 3, repeat step 1 here. Okay, repeat step 1 until you meet the given condition. This one given by the question. Maybe the question said until the error less than 0.01. So meaning you need to repeat this step until the difference between your answer, because in real world, basically you tak ada this value. This one not exist. Okay, that's why we apply the numerical method to get the answer. Okay, when you iterate, we call it iteration. When you iterate, the difference between your first iteration and your next iteration, okay, it must be satisfy the certain condition. Maybe it said the previous and the current must be less than 0.01, the difference between iteration. So this one is a condition given lah. Okay, it depends on the question. Okay, this not fixed, it depends. Okay, let's for the A, B is the same, but now A positive, B negative, so it's the same. We just need to change it according to the sign here. Later we see example. Okay, example now we have given x squared plus 2x minus 2 equals 0 has a root between 0 and 1. Find the root to one decimal place using the bisection method. Okay, so this is the question and this is the given condition. The question said you must get the root, that the root here must be one decimal place. Okay, if you use calculator, I don't know what is the answer at calculator, you can try it. Berapa answer from calculator? Here you can try. It should be the answer from the calculator. The root is 0.732, while the second one is negative 2.273. So between 0 and 1, basically this should be the answer. Okay, this should be the answer. And the condition given by the question here, it said must be one decimal place. Meaning when you iterate later, okay, maybe the first iteration, you get 0.71. Your second iteration, you get 0.73. So because they are now equal to one decimal, when you truncate the last number here after the 7, so you can stop. But if you get 0.6, for example, and then the second you iterate, you get 0.67, you still cannot stop because this one when you truncate, you get 0.6. This one when you truncate, you get 0.7. So they are different in one decimal place. So you still cannot stop. Okay, because the condition said must one decimal place. So they must be equal here after you truncate the second decimal place. Okay, so now let's solve for this example. We have x squared plus 2x minus 2. Okay, so this is the function f. X squared plus 2x minus 2, and it said the root between 0 and 1. So we have root here. Okay, first step, you need to get the value at 0 and also value at 1. Okay, so easier if we apply table. Okay, because we have many iterations to apply, and the step here basically repeated lah. Okay, so we make a table, nice table. Okay. Okay. First, we have the value of A, and then we have the value of B, and then what is the value of A, and then what is the value of B, and then we have the C, what is the value of FC. Okay, so A is 0 because question said 0 to 1. F0, you substitute here lah. F0, you get 0 square plus 2 times 0 minus 2, we get negative 2. F1 is, you get 1, negative to positive. C is A plus B over 2, the midpoint. So 0 plus 1 over 2, you get 0.5. Then FC is, you substitute 0.5 here. Okay, if you substitute, apa answer? Use your calculator. This one you can use calculator. Okay, numerical meaning you need to apply a lot of calculator. You need to use a lot of calculator to get the answer. Okay, here I get negative 0.75. Okay, so you look here, we have negative and A also negative. Okay, FA, FC. So A negative, A negative. So meaning you need to change this A value. We don't want zero. We don't want value 0. What we want now, you change this 0, you change to 0.5. Okay, meaning you change the one with the same sign as FC. So now C equal to A. So meaning we take 0.5 here. You substitute the A here now with 0.5. The one with the same sign as C. Okay, because the negative, this one also negative. You need to change A into C. C here meaning the new value. Okay, the one that you need to change whether A or B. So when you change A 0.5, B here you maintain it lah. B doesn't change. FA now you take the value of FC because FA here 0.5, so you get negative 0.75. FB just the previous one because the same. Okay, the same. And you need to get your C. C here, the current one here, 0.5 plus 1 over 2. Okay, so here we should get 0.75. And you also need to get 0.5 for FC, meaning you substitute into your function f. Okay, this function f, a lot lah, you need to apply it a lot. Okay, so what we get here should be, I get 0. Here I get 0.0625. Okay, and we notice here that the value is positive. Okay, meaning same as B, FB, positive. So meaning you need to change the value now. C become B. Okay, B equals C lah. Ni silap B. Not C equal A. What is the new value lah? C equal to what? Okay, C equal to what here? Okay, here C equal to A because same sign, FA and FC. Now FC positive, so you follow the FB lah, FB positive, so meaning C become B. So this now B changed to the third row. It is the, okay, now this becomes 0.75 while A here maintain 0.5. If A maintain, just take these values, negative 0.75 because you don't change it. But now B 0.75, take here 0.0625. So you repeat this. See, you repeat this process until satisfy the condition. The condition said the root must be one difference. Okay, here you have 0.5 minus 0. Doesn't matter lah. Here 0 or 1. 0 or 1. Okay, here negative 5. Okay, minus 1. Why we put this modulus? Because we can ignore the negative positive. Just the difference must be less than 1. So meaning the xi plus 1 minus the xi, the next plus the previous must be less than 0.01. It must be like, it should be like what? How you want to put in this word? Meaning the difference here, they must be, okay, you can put in word lah. Okay, if you're confused, 1 decimal place. Okay, we can put here correct to 1 decimal place. So now if you minus here, you get 0.5. So the difference is here 5. Okay, between the root 0 and also 5. Okay, here also you can put, okay, the letters we get C, 0.5 minus 0. Okay, here 0.5 and 1, here also the same lah. Okay, because the first one here basically kita tak ada lagi the difference. Okay, this one we still don't have the difference. But the second one here, you get, okay, you get like 0.5, and then here you might just minus your C, 7.5, right? Here 7.5. Okay, it should be 7.5. Basically, the first iteration, you still need to proceed lah. Okay, 7.5 minus 0.1 or 0.5, so you get 2.5. And then here, what is the new value? Plus 5, 0.625. Minus 0.5 is 0.125. Okay, you proceed your iteration until you get the difference in your C here, basically correct to 1 decimal place. Okay, so we look into the next. I already put in the answer. Okay, you get your A, your B. Okay, we get negative, so you change the negative, meaning you need to change your A here, change the A, become 0.5. So A becomes 0.5. B maintain, you proceed your calculation, then your C positive, meaning you need to change your B, become the 0.75. Okay, you change lah B here 0.75, you calculate until you get C negative, meaning you need to change your A. Okay, the E here is the error that I calculate, meaning the difference between the roots here should be 1 decimal. So this is our root lah, this is the root that we want to find. Okay, 5, 7, not equal, say 6, 2, is this one 0.6, basically 6, 8, you get 0.7 when you truncate, because the question said 1 decimal. 171 also 1.7, so here already equal, so you can stop, just stop, because already 1 decimal, so that's why we stop at the, okay, this one is second, the fourth iteration we will stop the calculation. Okay, the first one ni here 0 lah because kita dah start lagi. Okay, so that is the bisection method, where you just do the calculation, put into the formula until satisfy the condition given by the questions. Boleh, that's for bisection. Okay, the one with the same sign for the C, FC, the one with the same sign, that one yang you kena tukar the value. Okay, ada soalan? Tak ada. Okay, you stop until satisfy the condition given by the question. Okay, this one tak ada apa, sebenarnya just tukar the tu. Okay, maybe you can try this question. Okay, find the approximate of a root for the function x cubed plus 3x minus 2 in the interval until b minus a must be less than 0.01. That's the condition given by this. Okay, so you substitute, you put the table to make it easier for you to proceed the calculation. Okay, first you have A, you have B, you ada FA, we have FB, C is the midpoint, A plus B over 2, then you calculate your FC, okay, you're confused, here kita tak guna F, kita guna G, okay, because the question given here is G, okay, G, so G, so this one, whether you need to change lah, okay, what is the, your C become A or B, and here the condition B minus A, it said must be less than 0.1. You can put modulus here, doesn't matter, as long as dia mesti kurang 0.01. Okay, So A here 1, B is 2, okay, 1 plus 4 negative 1. Kalau 2, 8, you get 9. So C, what is C? 1.5. So you put 1.5. You get positive. Here 1.5. So C, B minus A, meaning the latest lah. You cannot use B. Okay, here 1.5 minus 1, I get 0. 1.5 minus 1. Doesn't matter, you can also put minus B. Okay, why? Yes, okay, nanti we confuse. Okay, we don't proceed here. Okay, C, A or B, which one? Kalau you rasa from here, which one you need to change, A or B? Which? Okay, which one guys? A or B? That we need to change, we need to change B. Betul? Because B positive, GC also positive. Okay. So, okay, answer already given. So, meaning now we need to change B. Okay, because here positive, B also positive. So, you need to change B. So, this now become B. No, sorry, 0, 1.5. 1.5. So meaning C here equal to B. This B yang you letak kat sini, meaning the latest one. Which one yang you can latest one? So B here, you ada 1.5 minus the next root lah. A ni akan maintain as 1. Okay, this A will maintain to 1. So minus 1. Here you get 0.5, which is greater than 0.01. So meaning kita tak boleh stop. You need to proceed the calculation. Okay, you proceed your calculation. Okay, proceed. A maintain negative, GB take from the previous. But here you need to do the new calculation. Okay, you stop until the difference between the roots. The next one here must be less than 0.01. Okay, proceed lah sampai meet the criteria. Basically in your, I don't know about that for your extended assignment, but in the final exam previously, the calculation may be up to 5 or 6 iterations. Okay, kalau when you calculate it more than like the range 5 or 6 to 4, 5, 6, meaning you mesti salah kira. Okay, because this numerical method just apply. If you ada mistake, that is when you can see your calculation to never ending lah. Okay, it never end. That's meaning you ada mistake in the calculation. Okay, so try this. Okay, they already mentioned 0.078, then you stop because already less than 0.01. Okay, so this is the answer. You can check with yours. Okay. We change it, we calculate this criteria. When we meet the criteria given by the question, then we stop. Okay, your condition too should be used to the new root, not the previous root. It must be applied to the new root. Okay, root yang baru. Okay, ada soalan? for this bisection, basically this is the bisection method. We complete already the first half of chapter 3. Okay, the second half is the Newton-Raphson. Newton-Raphson also same like this, but different formula lah, different equation. Okay, tak ada soalan? Okay, if no question, I proceed lah because we need to go fast to cater for your test next week. Okay, so example 2, this another examples. Isolate the roots of the equation power 3. Okay, find all roots. So basically power 3, the most must be 3 roots. Kalau 2 tu meaning the 2 roots must be repeated one. So now you have 3 roots because power 3. By using bisection with condition b minus a must be less than 0.25. Okay, you need to iterate until the difference must be less than 0.25. Okay, because this question is the question only. So they are not given to you the intervals. Okay, you need to find the intervals. So how you want to find the intervals? Because we know this bisection, they must be like cross the x-axis. Okay, there must be difference. You substitute A and B, they must be different in sign. Okay, must be here. Kalau you dapat, you punya function FA must be negative. This one, your FB must be positive. Okay, they must be different in sign. So for this question, you just roughly substitute values in the x intervals. Okay, so you here we assume, this one we just assume negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. You just assume. Okay, but take the values near to 0 lah. Okay, jangan tak 1000, then 1001, that one quite far from the 0. Okay, remember the roots must be close to 1 lah, plus minus 1. Okay, because x cube, this one condition that we learned previously lah. Okay, 1 here should be one of the root lah, because 1 times 1 you akan dapat 1, right? So you akan dapat x cube, but the intervals here, the constant here, when you multiply you should get plus 1. So 1 here whether positive or negative, so you need to try. Okay, that's one of the conditions. So you check the values that close to 0. Okay, so then from here, this one just random values only. Okay, random. Okay, you see here, make sure they must be have different sign. If positive, must be go to negative, C later. Okay, your C must be negative. Then kita ada roots here and here. So here if you notice, when you substitute negative 3 and 2, kita ada difference in sign, negative to positive. So this you can use as the interval from negative 3 and negative 2. Roots must be here lah, between this. Here no change in sign, positive, positive. So don't use these values. Okay. This one continuous, right? So should be okay. The one with the rational, you can apply this bisection lah. Okay, this one also difference. Okay, you ada negative to positive. Okay, here same, positive, positive, no need to change. But here positive to negative. So this one also the second interval. Okay, we ada 0 to 1. Negative to positive also. So this is another interval. Okay, this one is another intervals. 1, 2, 2. Okay, because you see the difference, so meaning there must be some roots, there must be roots here between these 3 intervals. Okay, so we do like the previous one, you make the table until the criteria meet, which mean the difference between B and A must be less than 0.25. Okay, here if you minus it doesn't matter lah. A and B because basically they are the same distance because midpoint. Okay, we know already C is midpoint. So you can use A, you can use B. So 1 minus 0.5, we get here 0.5. Okay, the second one here. Basically, we apply the second one, whether you need to stop or not. Okay, whether this one you need to proceed or not. Okay, here already meet. Because basically here still not satisfied because the question doesn't mention equal. Kalau equal, you can stop. But here it should be less. So you need to apply here again. Negative meaning tukar dekat A. So negative 1 point, no, it should be 0. We change the value of A go to C. So here should be C lah. 0.875. B, maintain 1. FA, take this, negative 1.83. B, maintain because it doesn't change the B. So you need to get the C here. C here, if I calculate it, soalan dia, x cube minus 4x plus 1. Okay, so if you substitute, so C here I should get, and the difference between this C and whether 1 or 2 is 0. So I get basically here this 0.0625, which is already less than 0.25. Then we can stop lah. So basically our roots is, because they are, you have two roots here, maybe you confuse later, mana lagi nak guna, take the value of C. Okay, you take the value of C. Okay, so you can proceed the next two intervals in order to get the roots. Okay, ada soalan kah? Okay, when we want to use this interval, basically bisection method, okay, semuanya guna intervals. Okay, all we need to use intervals. But okay, we check the difference between this example. This example one, the question already given to you the interval. Okay, given to you in the given interval. Okay, the previous one also mentioned between 0 to 1. So meaning our interval 0 to 1. Okay, the previous two examples. But the example 3 here, the question doesn't mention about the interval. It only said find all roots using bisection, using condition, this condition. So you can cari that intervals lah. Okay, how to get this one random. Okay, random lah, you need to substitute values, get close to 0, 1, negative 1, just take any values, and then we take, when they have different in sign, here you have the negative, positive, meaning you can consider the x interval there, take that value, where we have different in sign. Okay, negative, positive, so change, so this is our first interval. But here kalau you tengok from negative 2 and negative 1, okay, if you look here, negative 2, negative 1, we don't have different in sign F. Positive, positive. Meaning our graph still dekat positive Y. Okay, meaning your graph, if you can draw it, X Why? First, kita ada different in sign. Okay, because negative 3 and negative, sorry, bukan intercept kat negative 2. It should be like negative 3, negative 2, kita ada different in sign here. Okay, because negative pergi ke positive. But here when at negative 1, dia still positive. Okay, sebab still positive, positive. Kat 0 also, it's still positive. So meaning still positive. But when at 1, here 1, dia dah jadi negative. Itu faham. So meaning we know already there must be some root between here. Okay, because change in sign. Here also change in sign. Okay, here it go to negative 1, no confusion ni, negative 2, right? Then bila dekat 2, it change to positive, meaning this one must be like they go back to positive. Okay, then 3 and 4 they just go to positive lah because 16 and 49. So this one also another root between 1 and 2. Okay, that is the graph lah. Kalau we refer to that graph. Okay, because the question doesn't give the interval, we need to find the interval. Okay. Alright. So basically, we already done the first part. So try whether you get what is the answers here. Okay. Now for the intervals, negative 3, negative 2, and also 1, 2. Okay, what is the root? Okay, so I think you buat lah. So itu pun dah habis dah. Nothing to the Newton exercise. I think next week because we don't have enough time to cover Newton. Okay, enough time but cepat sangat pula. Okay, one thing to mention, we have test 1 next Wednesday. So I want to cover chapter 3 and 4 next week. Okay, chapter 3 just the another method. Newton Raphson same like this. You need to make a table later, apply the formula. 1 hour can be covered. And chapter 4 maybe 2 hours. Okay, 2 hours. So we need to do replacement because I still remember we still not cover the 2 hours at week 1. Week 1 kita tak buat kelas because you guys just register on Thursday. So we still have 2 hours lah because we just replace for 2 hours. Okay, can we do it on Tuesday? Pastilah because our class is on Monday. Is it possible, guys? On Tuesday. Okay, do you guys available on that day? Can Alright, because yalah, we have test 2 on the Wednesday. What time? Itulah tak tahu all. Or I need to refer previous time like what we did on our first replacement lah. I think that one during morning, maybe 12 to 2. Not mistaken lah, 12 to 2 or 8 to 10 the previous one. Okay. 12 to 2 kan, so maybe 10 to 12. Okay. As long as we can cover the chapter 4, should be okay. Because chapter 4 also not so many. You learn already about the matrix during your foundation previously. Replacement. Test Wednesday. Test 5 August. Okay, we plan to okay, test. Replacement kan. Okay, try dulu. Okay, what is your answer? You can use your calculator to check. Okay, it doesn't matter. But your answer must be not correct to this one with the calculator. Why? Because we use approximation method. teknik buat your calculator tu mesti ada certain formula lah yang kita dah guna. Okay. Tapi calculator pun dia, in your calculator also basically the built-in function there must be like some technique also to calculate the value. X cube lah, kalau x square tu boleh guna the b square tu. Test pukul berapa? Our test ni special sikit. Dr. Dennis plan to open until midnight. Dia special sikit, like extended assignment lah. So the duration tu lama. I don't know, maybe I don't know how many hours. Okay, maybe one day, we don't know. Okay, but the duration dia lama. That's the important one lah. Okay, replacement bila hari Selasa? Not on 8 sebab 8 tu ada maintenance for UTP, internet at UTP, so cannot do at 8 lah. That's why we make it earlier, sebab kalau nak buat on week 11 tu dah lambat sangat. Okay, later cannot have time to cover the to mark lah also. Okay, so boleh tak replacement on Tuesday? 10-12 kan lah, so we do it and so maybe the class on the Wednesday tu I change to the tutorial lah. Okay, because basically we can cover this, not so many, just we want to cover before your test. Alright, so replacement Tuesday. Okay. Okay, so you try to do this. You can check with your calculator also. Or you want to try to fill in the values, give me the values, then I substitute here. Okay. Tapi senyap je. Okay, try it. If no question, I think we can stop here lah. Okay, try buat this question. And I think that's all. If no question, you can dismiss, but make sure you sign in your Power Apps and also do the self-inspection post there. Okay, if ada soalan, maybe you can state. If no question, we end here lah. Okay, thank you. Power Apps not working, you can use you can use the Microsoft Office form previously. I need to open it. Okay, you can use the Microsoft form here. Okay, quiz malam ni jangan lupa 4%. Okay, tak ada soalan If no question, I end the class today. See you next week. Thank you.